Alright, so today we're talking again about solving systems using substitution. So, remember you need to have one of the equations solved for either x or y, and then you substitute that piece that it equals into the other equation. Okay, so here, neither equation is solved. Now if you notice, this top equation is going to be the easiest to solve for y. So I'm going to add the 3x to both sides. And I get y equals -7 plus 3x. So from here, I can now take this piece and plug it in for this y. So I have -6x plus 2. Then I can plug in the -7 plus 3x equals 1. So the first thing I want to do is distribute my 2. So I have -6x minus 14 plus 6x equals 1. Here's where I combine like terms. I've got -6x plus 6x. That goes to 0. And I end up with -14 equals 1. Now, is that true? Does -14 equal 1? No. So this would be no solutions. Beautiful. That actually turned out quite nicely. Alright, on this next one, the bottom one is going to be the one that's easiest to solve, and we can actually solve for either variable. Since the last one we solved for y, I'm going to solve for x on this one. So I'm going to subtract y from both sides, and my new equation is x equals -7 minus y. So I'm going to take this -7 minus y and plug it in for my x. So this is going to be 2 times, here's the -7 minus y, and then plus 3y equals -6. From here I distribute my 2. I end up with -14 minus 2y plus 3y equals -6. From here I combine like terms. -2y plus 3y is a positive 1y. And I don't really have to write the 1, so I'm just going to write it as positive y equals -6. From here I would add 14 to both sides. And I get y equals 8. Okay, from here I can go ahead and plug this 8, and my favorite equation to plug it into is going to be the one I've already solved for x. So I've got x equals -7 minus, and here's where I plug in my 8. Well, -7 minus 8 is -15. So then my solution is -15, 8. So that is the solution to my system. Alright, let's do another one. Okay, here I notice immediately that this x is only 1x, so this one's going to be the easiest one to solve for x. So I can add 4y to both sides. And the new equation is x equals 11 plus 4y. So now I'm going to take the 11 plus 4y and plug it in for my x. So I have 4y minus 5, and then we're going to do 11 plus 4y, because that's what I'm plugging in for my x, equals 9. From here I distribute my -5. So I have 4y minus 55 minus 20y equals 9. From here I'm going to combine like terms. So I've got a 4y and a -20y. So that becomes -16y minus 55 equals 9. From here I can add the 55 to both sides. And I get -16y equals 64. And from here I can divide both sides by -16. And I end up with y equals 4. Alright, so from here, we can see that we've got y equals 4, and we can go ahead and plug that in. So that makes this 11 plus 4 times 4. So this is 11 plus 16, which is 27. So I have x is 27, and y is 4. Alright, this will be the last one for today that I help you with, then you got some to do on your own. Alright, so right here I notice immediately that this is probably going to be the easiest one to solve for a variable. So I'm going to subtract 10 from both sides, and I get negative x equals 6y minus 10. And I need to get rid of that negative 1, so I divide everything by negative 1. And I get x equals negative 6y plus 10. Now I can easily take this negative 6y plus 10 and plug it in for this x. So that means that this becomes 5 equals 1/2 times negative 6y plus 10 plus 3y on the outside. So 1/2 distributes through the parentheses. This becomes negative 3y plus 5 plus 3y. So now you might notice negative 3y plus 3y, that makes the y go away. We end up with 5 equals 5. Well, if 5 equals 5, that's always true, so this is infinite solutions. Because they're the same line. If we were to graph these two, they would end up being the same line. Well, that's kind of fun. Alright, now I want you guys to go ahead and do these two, and these two, and then write your recap, and you are done for today.